Fabulous. Right, welcome. This is the first go at doing this, so apologies if it either just takes too long or I make a mistake, or if the technology doesn't work because we had some issues with Teams today. But fingers crossed, it'll go along without too much of a hitch. Right, so I'm going to share my screen and go through a presentation which has got sort of snippets of the question, so we can just look through question 10, which is the battleships question, the algorithm question. Okay. There we go. And I'll start this. So there's the question as a reminder. So a developer wants to simulate a simple version of the game Battleships. Now, it describes the game and it also gives us the information that this is a one-dimensional array called board. I will get the pointer so I can sort this. So when I first looked at this question, I immediately imagined the actual game Battleships with the full grid, which is a multi, dimensional array, okay, or a 2D array. We've got you might go across 15 squares, but then it would also go down 15, so we end up with a square shape. Now this question, the board is just what you can see here, so it's 15 squares across. Now we've got an example here. We've got a carrier of 3 spaces, a carrier with 1 space, carrier with 2 spaces here. The size of the board is always just 15 squares, so it shows us that in figure 9. So this one here would be board 1, board 2 and board 3. The next step tells us the information, what we need to know in terms of what happens if a board is hit. So if it's empty, we have a 0. It's got a 1 if there is a ship at it, but it's not been hit, and a 2 if it has been hit. And then we've got a subroutine here. Identifies one of the subproblems and creates a routine. So subroutine F, board and location. H is board location. If H equals 1, then return true, else return false, end if, end subroutine. Now this is perfect because what this does is it already tells us what a subroutine would look like. So we can see that we have, if we're going to write an algorithm, we're going to write the pseudocode for a subroutine. We start it with subroutine and we finish it with end subroutine. So that would help us when we come to do the question later on, which is the 11 marker. And we will come back to this, but this is really useful because it gives us some information about the structure of a subroutine. A reminder that anything that is in these brackets here, these are our parameters. Now this particular subroutine takes in 2 parameters, board and location. Now, question 10.1 was reasonably straightforward in terms of data types, although lots of people got this question wrong. So the subroutine in figure 10 uses the values true and false. Each element of the array board has the value 0, 1 or 2. What would be the most appropriate data types for these? So this is the value, true or false, and then that's where the data type would go. So the data type, now I'm going to badly do this, but I'm going to try and write in here. So that would, oh no, that's looking okay. Boolean, okay. I'm not going to do this for all of them because that'll just look terrible. Boolean. And then 0, 1 and 2, that data type, they're whole numbers. So we use integer for that. Okay, so they would be integer. 10.2, the developer's taken a subroutine, the overall problem and has broken it down into smaller subproblems. We did this, I don't know if you remember, but we did it at Key Stage 3, and it's all to do with problem solving. Computational thinking was the term, and 2 significant parts of computational thinking. We've got one, which is abstraction, and that's taking out anything that's unnecessary, and then this one here, which is decomposition. Okay, that's what we were looking for there. oh, this could take forever. You know what I mean? Decomp. I'm just going to write. I'm not going to attempt to do any more writing on there. It'd be all right if I had a fancy computer with a pen that I could just write on the screen, but I don't. This is from school. Okay. So next question. The identifier for the subroutine in figure 10 is F, which is not a good choice. State a better identifier. So for this, we really need to work out what we're trying to do here. So what is H? So sorry, F. Where are we on? Subroutine F. What is this subroutine actually doing? And therefore, what do we think would be a better name? Now, the purpose of this is to work out what's not been hit, because what we're looking for each board location in this subroutine, so H is the board location, and this, if H is 1, then true, else it'll be false. So we're trying to work out if a particular location is equal to 1. And we already know from previously that if the value is 1, it means it's not been hit. So this subroutine is working out what's not been hit. So a better identifier there would be not hit. Now, it's important because it would make it so much easier at a glance to see what that subroutine is actually doing. So that's why. Okay, and that would be your explanation there. Makes your code easier to understand. If someone's coming in, it's easier to debug. Lots of reasons there. So the variable H in the subroutine in figure 10 is local to the subroutine. State 2 properties that only apply to those local variables. I think I did speak about that in lesson, and that is that a local variable is only used in that subroutine. It doesn't exist outside of that subroutine. Right, so now we get to the bit that's the tricky bit, and this is to do with how we actually put this algorithm together. Now, how we approach this is we work our way through the bullet points, because it tells us exactly what we need to include. So our subroutine should have a sensible identifier. We've already sort of looked at a few, the question before, talked about that. We're going to take the board as a parameter. So I've spoken about that with you in terms of in the brackets. And then we're going to work out and output how many hits have been made. And then we can work out how many locations contain a ship have yet to be hit. We can do the winner and almost there. So first things first, tackling this question. It says have a sensible identifier. So what you need to work out really from here is, well, what is this algorithm doing? Well, it says here at the top, it wants us to work out an algorithm, a subroutine, how far away the game is from ending. Well, that working out something to do with that is going to be the best identifier there. So we open the subroutine here, subroutine, how far away from ending. Notice I've just put capitals every other word to make it slightly easier to read those distinct words. And then number 2, take the board as a parameter, and that just goes at the end there. Now, I've put subroutine in here, but obviously if you were doing this in exam, you wouldn't write end subroutine before you'd written your algorithm, because you probably wouldn't know how long it's going to be. I've just put it there to remind you that if you start a subroutine, try to remember to end it. I don't think you'll lose any marks if you didn't put it in there, but it is worth including. Right, next step, work out how many hits have been made. Now we're going to need to use a variable to do the counting. So you're going to, we need 2 variables here. We need a variable to count the hits, and we also need a variable to count what's not been hit. So again, using sensible identifiers. What I noticed with some examples when I was marking your mocks is that some people used A, B, or F, G. Those letters aren't going to help anybody understand. And particularly if an examiner's reading your algorithm, you want to make sure that it's clear for them. So you want to make sure that they can read those. This next part is going to loop through. I'll just move that. So we're just going to loop through the board locations to work out if any have been hit. So this for loop, we're doing for, so X, remember that's just our counter. We might use I in Python as an index. You could use I in your pseudocode, that would be fine. So for X, 0 to 14, because that's going to start here and end there, making sure we cover the whole of that board. If board X equals 2, then hits is hits plus 1. So it's going to loop through 14 times and it's going to check the contents of each of these and see if it's 2. If it is, then it's been hit, so it would increase the hits by 1. Next step. Hang on. Hang on. Right, just give me your hands up to check you're all still there. Yeah, good. I just had my PowerPoint, I had a little bit of a blip then.
I'm not here.
You're not here, thanks.
Wait, yeah, no, sorry, yeah.
Yeah, thanks for that. Okay. Are you still seeing my screen?
Yeah.
Yeah, okay. Right, let me try this again then. So, there we go. So the next step, once we've worked out and counted how many of the locations have been hit, we then need to work out what's yet to be hit. So this one was part of the, we were using selection here. So if it's 2, then we know it was a hit. Else, what we're going to do then is we can use another if to check if it's a 1. So if the board X equals 1, then yet to be hit is yet to be hit plus 1. So it's doing the same as it is up here, but we've just nested it so that then we can then end it. So not a 1 or a 2, then nothing happens there. Okay, and once it's looped through that 14, those different 15 locations, sorry, then it ends that loop. And then we would output the hits because it asked us to. That was one of the questions, output the number of hits. The final algorithm would look like this. So we can see just at the bottom here, I've lost my pointer. So that's where we got up to. So lastly, once we've done this and we've counted up how many hits and how many we've got yet to be hit, we can then output either winner or almost there using some more selection. If yet to be hit is 0, then output winner. Else, if yet to be hit is less than 4, then output almost there. And then we can end the if. Okay. Now, I'm just going to stop presenting there. All the little things disappear. Don't make it very easy for me there. Right. Are there any questions with that algorithm? Does anyone have any questions? Put your hand up if you do have a question. No? Let me just show you the mark scheme before we finish, and I'll, what time are we on? That was a lot quicker than I thought it would be. That's good. Let me find the mark scheme, and I'm just going to show you. So I'll go back to my thing. Where are we? There we go. So in the mark scheme, this is what you get marks for. So 11 marks. You get a mark for creating the subroutine with an identifier that defines its purpose. And you also get a mark for passing the board as a parameter. So just that first line there gets you 2 marks. So if you could do nothing else, but you could just remember, because we'd already seen how to do a subroutine from a previous one, that's 2 easy marks there. Okay. Then we've got another mark for passing the, using the indices or something similar to identify the value of each cell. So the 4, so that's this here, 4x is 0 to 14. Including that and knowing that you would need to loop through that number of times, it wouldn't matter if there was nothing in here or if what in here was wrong, you would still get that mark. So all of these marks here, and what I'll do is next lesson, I'll give you a printout of this so you can keep it, or I tell you what I'll do, I'll save it into Teams, but you can just have a look at that and read through and see the different places where you'll get your marks up to and including 11. Okay, so let me stop sharing there. Is our lesson tomorrow? I don't think it is, Adam. I don't think so. My timetable's in my bag. Any other questions? When do we have it next? You could check your timetable. Let me have a look. My plan is all the way in my bag. Tomorrow. Oh, it is tomorrow. It must be period 5 then tomorrow. I'm going to stop recording. 3 and 4 tomorrow. Okay, right. Well, I guess I'll best get planning then once I've finished this and make sure I know what I'm doing. All right. Okay, Adam. I'm going to go now, or I'm at least going to stop recording. That's probably a good idea.